We do not advocate again. Okay, good morning, ladies and gentlemen. I'm now recording. As mentioned yesterday and previously, today's tutorials are going to focus on recursion. Mr. Van der Westhuizen has put a nice set of slides together for us to explain the recursion a bit more in depth. So the agenda is to go through recursion, get you guys a bit more comfortable with it, show you how to do a trace table. Hopefully I'm giving the right term. And then we will be doing, then we can answer additional questions about the practical if need be. Just one thing, ladies and gentlemen, I picked up from yesterday's lecture. Please keep the questions in line with what we're doing. We've put a notice up on Eve. I'm going to do it in class as well. When the lectures are on, please keep the questions focused on what we're doing so we don't go off topic or diverge from what we need to do. We still have plenty of time in the semester, so it's not an issue from what happened yesterday. But please, during a theory lecture, keep your questions about the theory. During tutorials, you can more than welcome to ask about practicals at the end. We're going to try and reserve the majority of the beginning of the lectures for questions about what we're going to do. Questions near the end will be practical based. Okay, I got a question again. When doing recursion, if there's multiple base cases, do you use Moses? For that situation, you'll have if statements. I wouldn't go with select cases. You'll see we'll actually have an example of Fibonacci with two if statements, or actually two if statements to handle the two base cases. So that should answer your question when you get there. Okay, so let me just kick this into Power. Slides, okay. So here's a nice definition of recursion. Recursion functions are classes of functions that are naturally number suited, number studied in can't talk properly this morning, are a class of functions on the natural number studied in compatibility theory. Okay, basically, if I understand this correctly, recursive functions are very, very good for mathematical functions. Okay, your Fibonacci, your factorial, the sequence 3 we gave you, they're very well suited for those type of mathematical equations. They don't fit everything. Recursion isn't the solution to every single problem. If, as you notice from the theory lectures, whatever recursion can do, iteration can do it as well. Okay, it's just sometimes easier to get it done using recursion because it allows you to break down a very complicated theory into very simple steps. And that's the point of it. We're breaking things down to simple steps. I'll let you guys read that in your own time. The factorial, so things to consider with the recursion. What two components is needed in a function to have recursion? Ladies and gentlemen, base case and what's the other one we need? Recursive call, excellent. Good. So we need to know our base case and we need our recursive call. And that's what you kind of see in front of us right now. That's our base case. No, back. Our base case is factorial of 0 and factorial of 1 is 1. That is our base case. So those identify our base case. I'm going to try and switch something here. Hopefully you guys can also write on it. Okay, you see the lovely whiteboard. So our base case is factorial of 1 equals 0, 1. And our second base case is a factorial of 0 equals 1. That's our base case. Our recursive call is n times n minus 1 factorial. Okay, that's our recursive call. These are our base cases. Is everyone okay with that idea? So with maths, there's always this type of setup where you have your base cases where you know the given value. We know the value of 1, we know the value of 0 by default. They are given values. In the mathematical equations, those are given to us. And then they give us the formula for the rest. But the only two that we actually know an answer to is that. The rest we actually don't know an answer to. Okay, offhand. Those are only ones we can guarantee we know answer to. So these form our base case. This forms our recursive call. Does that make a bit more sense in terms of the differentiation, ladies and gentlemen? Okay. No. No. Why am my thing's trying to share things? Application, share audio, Windows. Why is it going all over the place today? Okay. Blackboard isn't working with me. Okay. So from there, we get our recursive call. So, and is this wrong what's happening on the screen right now based on what I just showed you? Do we need a second base case? Yes and no, actually. You could. There's no issue saying if x equals 0 or x equals 1, return 1. But let's consider the facts. If x is 1, it doesn't return 1, it goes here. Else, return 1 times 1, which gives us see if that's paying attention. What's 1 times 1? Good, 1. Okay, so this is a recursive function for factorial. So now let's look at it. If we call factorial 4, f of 4, is it going to return us 1, or is it going to run the recursive call? Okay. I'll come back to your thing. Okay, it's going to return the recursive call. So it's going to call x times factorial of 3. Then it's going to call x times, or 2 times factorial 1. Then it's going to call factorial 1, which is 1 times factorial of 1, which is factorial of 0, which gives us 1. Now we have our 1. We can start to loop back. We can start to return. Okay? So we return 1, then we return 1 times 1, then we return 2 times 1 times 1, then we return 3 times 2 times 1 times 1, and we get our final answer 4 times 3 times 2 times 1 times 1, which is 24. So remember, we build a stack. Every time we call a function, we're building onto the stack. Once we have a solid answer, we've got to start removing from the stack, and that's what's happening here. We're removing from our stack and returning values. And we get 24. Okay, is everyone okay with the factorial? Does it make a bit more sense now? Okay, I've got some no's. Where did I lose you? Actually, I've got 2 no's. I've got 2 no's, yeah. Where did I lose you guys? Give me some idea, please. Okay. While I'm waiting for those 2 students, majority of you are quite comfortable with this. I'm going to move on. I'll come back to the questions. Just Right, type them out because I'm not sure where I lost you. Yeah. So the next one is Fibonacci. Fibonacci we've done in class, but unfortunately I messed up the drawing out. So we're going to have a look at a better approach today, thanks to Mr. van der Westhuizen. Now, Fibonacci is the golden ratio. It is something that is one of the most famous mathematical sequences. It also and actually shows up in a few places in nature. Cyclones, DNA, solar systems, shells, flowers. A lot of things use the Fibonacci ratio, the golden ratio, to almost be designed. So it's something that's quite. If you hear my dog barking, I apologize. So it's something that appears quite common in nature. So here, going back to a question earlier from Zita, if we have, I think it was Zita, or no, Moses, about multiple base cases. Here we have multiple base cases. We have a base case of x equals 0, which is 0, and x equals 1, which is 1. So if we have multiple base cases, we can have a situation like this. Just remember, don't use else if. I'm not sure if Prof. Long allowed it. I don't allow it. This is more pseudocode, so it's not an issue. Don't use an else if command in your VB code. That is something that is specific to Visual Basic by itself, and it's just annoying. So here we have multiple base cases. So remember, Fibonacci, let's just go back to our whiteboard. Okay, we have our base case of fib of 0 equals 0. And we have our other base case of fib of 1 equals 1, if I remember correctly. Now, anything else, fib of n is equal to fib of n minus 1 plus fib of n minus 2. So again, our base case or base cases are recursive call. Okay, we know the answers for 0 and 1. Beyond that, we don't know. We just know the formula. Okay, and we don't need to know anything else besides the formula. There's no need for us to go and try to figure out a sequence or anything. The sequence is given to us. It is the formula. So from there, we start working. From there, we start to, got a hand raised. You can talk. Or you can type, your choice.
Sir. Hello, sir.
Yeah, I can hear you.
Can I please ask, how do you get Fibonacci Fib 1 is equals to 1 when the Fibonacci sequence is like you add the previous 2 terms to get the next term? How is Fib 1 equals to 1 because the previous term is 0?
0. Oh no, it's the Fibonacci sequence or Fibonacci rule. Let me just Google it quickly. It's not something I've made up, and I can't explain the mathematical equation behind it. I just know from calculus. If you look on screen now, look, Wiki's not a reliable source, but this is the Fibonacci sequence. They say that basically it's like the assumption. They assume 0 is 0 and 1 is 1. Done. And that's the standard. So there's a sequence here. I can't highlight it though. Don't know why. There it is. Okay, so it's not something that I'm just sucking out my thumb. It's actually a standard thing. If you look in your calculus textbooks, you'll find Fibonacci as this. It's almost a theorem. Or it is a theorem. Let me change that. almost. That's why I can say that. It's not something that I'm just making up on the spot. It is something that is the basis of the Fibonacci sequence. So that's why I'm using it as a base case. Does that answer your question? Why can't we say, okay, Moses, good question. Why can't we say if it's less than 1, return 1? Because 0 is 0. And Fibonacci is built on a plus approach. So if I say plus plus, it'll increase the value, or it'll give you an offset of 1 extra every single time, which will cause an error. Okay, we have to stick to the base case. You could say n like I did in class, yes. So if it's 0, if it's n is 0 or 1, return 1, the nth value correct. But if you're not comfortable with, you can go with the standard default approach that I'm showing now. That you say if it's x is 0, return 0. If x is 1, return 1. Else return Fibonacci of x minus 1 plus Fibonacci of x minus 2. This is a standard Fibonacci. Notice there's no times anywhere. There's no x here. It's just Fibonacci plus Fibonacci. So it's not the whole sequence added to up. It's just the previous 2 terms added together. It's always just the previous 2 terms added together. So let's look at an example of Fibonacci of 4. Fibonacci of 4 will return f of 3, f of 2, which then, this is where I was getting a bit stuck with demonstrating. Since every time we call Fibonacci, it runs 2 functions. Excuse me, it runs 2 separate stacks almost. So here we run down the 3. So f of 3 is f of 2, which then produces f of 1, which returns 1. Okay? And we then start breaking it down even more. But let me just go through this step by step. So f of 4 gives us f of 3. Okay, so we're focusing on the first half, and then we're going to focus on the second half, because both of these combined will give us our result. So f of 4 is going to give us f of 3 and f of 2, but we're going to focus on f of 3 to go down first. F of 3 gives us f of 2 and f of 1, and f of 2 gives us f of 1, and f of 2 also gives us f of 1. So we get, here we finally get 1 and 0. So 1 plus 0 gives us 1, which is f of 2. Okay, then we return up, and we get 1 plus f of 1, which gives us 2. So f of 3 is 2. This, I know it's going to be, so we have 2 plus Fibonacci of 2. So going down the rabbit hole almost for f of 3, Fibonacci of 3, we get the value of 2. So all of this produces the value of 2. Because f of 3 is equal to f of 2 plus f of 1. F of 2 is equal to f of 1 plus f of 0. 1 plus 0 is 1, which gives us f of 2, 1. F of 1 is 1. 1 plus 1 gives us 2, which is Fibonacci 3. So now we need to work out Fibonacci of 2, because that's the one we haven't done yet. Fibonacci of 2 gives us f of 1 and f of 0. So f of 1 returns 1, f of 0 returns f of 0. So 1 plus 0 is 1. So we have 2 plus what? 2 plus what? Let's see if you guys, if I've explained this okay. We've got 2 on this side. What are we adding on this side? 2 plus what? 1. There we go. Good. So this f of 2, Fibonacci 2, gives us 1. So Fibonacci of 4, final result is 3. Okay, so Fibonacci of 4 gives us 3, and all of this is just to get 3. It is quite in depth, but look at the simplicity of the function. Look how straightforward the function is. The function is very elegant, very smooth, easy to read, easy to understand. What's happening behind the scenes, not so much. What's happening behind the scenes is a bit more complicated. And to try and get this into a for loop or while loop is a lot more effort. It's more effort than it's worth compared to doing it using a function, using recursion. This is why recursion blends so well with mathematical functions, besides the fact that programming is built on mathematics. Okay, for those who hate maths, remember you're studying a field that's built on maths. So what we're trying to do today is illustrate how useful functions are and try and illustrate how functions are being called. So each of these are being added to the stack and then removed to the stack to finally get our answer. Okay, I'll address the green line in a few minutes. Let's just finish what's going on here, and then I'll explain what the hell the green line is. Any questions about Fibonacci or factorial? Ladies and gentlemen, everyone okay with these two? If you're not, please say so. If you're unsure of recursion as a whole, say so. Hand raised, go for it. You got a question?
So regarding factorial, does the order matter as to how you go about answering it? Like multiplying from 5 times 4 times 3 times 2 times 1? Can we actually multiply the other way around, like from 1 to 5?
Yeah.
When it's 5 factorial?
Yeah, you can. There's no issue.
Okay, thank you.
The design. This is just showing. Remember, what we're trying to show here is how the stack is returned. So it's going to return 1, then it's going to return 1 times 1, then it's going to return 2 times 1 times 1. So that's how it's going to return the values. How you calculate it, I'm not too concerned, but depends how you write it. This is the standard factorial approach. So it's x times the value. Don't swap that around, please. Okay. Any other questions of Fibonacci or factorial? I want to show you the trace table today as well, which is quite important. And we're making good time as well, so that's excellent as well. Any other questions, ladies and gentlemen? Post them up. I'm going to quickly get a slide on. I'm going to get a question to work through for a trace table. Okay, I'm not sure recursion as a whole. Maybe the trace table will help you with that, with understanding recursion. I'm going to quickly find a trace function to work with. We will work with the one at the end of the lectures on lecture 1, I believe. Yeah. No, I don't make any changes. Okay. So let's make sure you've got the same screen as me. Yes. Okay. So let's have a look at this setup. Okay. The reason I want to do a trace table with you guys is this is something that we often do in our semester test and exams to test your ability on understanding recursion. Okay, because this will test your ability to understand how recursion works and what happens. Okay, so how would we solve this? If I give you this and I say solve it in terms of x, y, and z. Okay, no values, no 1, 2, 3, 4. I don't want a value like 25. I want a value in terms of X, Y, and Z. I want a general answer. So I'm going to show you how to do that. For that, I'm going to need Excel just to draw it out. Okay, just zoom in a bit. Too much. Okay, while I'm zooming in and adjusting that so it's visible, what value is actually changing every time this function runs? Let me ask you that. Have a look at it. What value is changing all the time? Why? I got an X there. Okay, first thing you need to identify is which value is changing. Okay, so I'm getting a lot of Y's, good. When does it stop? What is its base case? Okay, good. When Y is less than or equal to 2. Okay, so that's our base case. That's the first thing we need to know. Also here, assume Y will always start bigger than 2. Okay, so we go with the assumption, assume Y equals 6. Everyone okay with that? So I'm going with the assumption Y equals 6 because Y is the one changing. Okay, Y is the one that's changing. I'm going to leave X and Z as X and Z. I'm not going to change those. So when I first call this, it's calc X 6 Z, which will give us X times Z plus calc X. What's the value of Y now? What happens to Y every single time? Y decreases and becomes 5, good, and Z. Now that then gives us calc X 5 Z, which gives us X times Z plus calc X 4 Z. Okay, which then gives us calc X 4 Z, which gives us X times Z plus calc. Yeah, we keep going until the base case. 3Z. Is 3 the base case yet? No. 3Z. Okay, which gives us X times Z plus calc X 2Z. Is calc X 2Z a base case? If Y is 2, is it the base case? Yes. So this one returns us this just returns us Z. Okay. So it just returns us Z. So now we have our stack. We need to start removing the stack. So it is XZ plus Z. Okay, because X times Z plus Z. Everyone okay on how I got to that step? The value of calc X 2Z is Z. So I'm returning the Z. So X times Z plus Z. Because remember, I'm taking up. I'm moving this value up. Because now I know the answer to this equation. The answer to x comma 2 comma z is z, whatever the hell z may be. Okay, I'm not concerned what z is. All I know is I'll return z at this point in time. I'm hoping the person that said no is okay now. Does that make sense? I'm moving back up. Okay. So now we know the answer to calc x3z is that. So we can replace this part with that. So it's xz plus xz plus z. Okay? Because we've taken the first path plus the actual result for that, which is that. So all we're doing is substituting back and returning the actual values. So as we move up, you'll see a pattern will occur. And we get to the final one, which is x z plus xz plus xz plus, and be very careful with this. Don't make mistakes by missing out a symbol. So the assumption is that calculate x of calculation of x comma 6 comma z will give us xz plus xz plus xz plus xz plus z. I'll do it again, but I'm not finished yet. This is the problem. We need to break this down into a more simpler version. So, okay. I'm seeing the question as that actually relates to the conversation. Are we allowed to assume y is any value greater than the base case? Yes. I'll pick 6. You need to assume it's a value big enough to actually get a value. So you can't just pick 3 and go with that. You've got to have a large enough value that you can see the pattern. So how many times is xz plus xz plus xz occurring? We've got to now break this down one more step. 4. So it's 4 xz plus z. Everyone okay with that? Is everyone okay with how I've gone from here to here? Now I might mess you up a bit more because I'm not finished. Final answer is this. We've got to take it in terms of x, y, and z. We have it in terms of x and y, but not x and z, but not y. So the base assumption was y equals 6. So y minus 2 times xz plus z. This is the final answer. So no matter what value of y I give, that'll be the final answer of this specific function. Okay, the rest of you are wondering like how the hell or what the hell. How did I go from 4 to y minus 2? Okay. Okay, yeah, some of you have got it. But I'm also speaking to people that are going to be watching the recording. Y 6, I need to relate 4 in terms of 6. So how do we go from 6 to 4? Because you've got a situation of y equals 6, but we got a 4 here. So how do we translate it across? Okay, so we go and say that to get this equal to 4, it's minus 2. So y minus 2 equals 4, which is 6 minus 2 equals 4. Oh, definitely. The last student, I understand the y minus 2, but is incorrect to use 2 times y. No, it's completely incorrect to say 2 times y. Because remember the assumption at the beginning was y is 6. So if you say 2 times y, you get 12. Yeah, okay, someone corrected him there. Okay, so that's that's actually how we ask questions in semester tests. So what I'm going to do now, I'm going to go quiet for a bit and make you guys do some work. Semester test 1. That'll work. Okay, ladies and gentlemen, everyone can see the question on screen. I want you to try do this yourself. I'll come back to the coding. I'm going to first finish off stacks, a trace table. So try do this. I'll give you guys 6 minutes to try and solve this one, and then I'll do it with you. So I'm going to go quiet for a. Okay, so please take out a piece of paper on your computer, however you want to do it, your choice. But try do this. I'll give you guys 5 minutes, and then we'll discuss it together.
Yes, you do assume it for any y value. Just keep in mind that the purpose of the recursive function is so that you can handle y if y is any value. So y can be anything, anywhere on the integer range.
Okay, ladies and gentlemen, one thing that is important to do is to show the calculation. Don't just write it as A, B, C, or X, Y, Z. Do show the calculations as it's worth 5 marks. If you make one mistake, you lose all your marks. Okay. So if you look with this question, if you get it right, you get 5 marks automatic. It's 5 marks given. But if you make a mistake, we then look at your calculation to try to see if we can still award marks for your process of thinking. So be careful with that. That's what I look funky. Anyone done yet? I've done in Excel will get you 5 marks, yes. Yes, I'm done. Almost. Okay. We still have 2 minutes, so it's fine. Okay, ladies and gentlemen, the reason I'm saying 5 minutes only is, remember, in the semester test, it's a 40-minute paper. So you need to be able to do this fairly quickly and fairly accurate, so you don't waste time as you move forward. So be careful of that. If you find this difficult, rather leave it for the end, maybe. Focus on things you can do quicker. I will be explaining it again. I'm actually going to go through this myself with you, don't worry. Let me just get the answer. Okay. For those who are maybe battling to understand it, I'll go over it again as much as I can, but also rewatch the videos, and Mr. Van der Westhuizen will be doing this again this afternoon as well. So there's a second explanation coming in this afternoon as well. He will explain it most likely he'll explain it his way, which is sometimes more technical than mine. So you might be able to get it there. But practice is the only way to get through this. It's been 5 minutes, roughly. What is the answer, ladies and gentlemen? Let's see who's actually got it. Remember, in terms of X, Y, and Z, Mm. Um, I see only maybe one person with a semi-right answer, I think. Okay. Ishma explaining. I think I need to explain it a bit better, ladies and gentlemen. I've seen two people with the right answer. I think I might be wrong. We'll find out. The last one, no. No. Okay, let's do this together. I might be wrong. I just roughly quickly calculated it. Yeah. So, everyone okay with it? I'm just going to move it off screen so I can do this calculation without being hindered with it. Okay, so we start with the assumption, assume x is 6. Actually, no, it's a bit too high, 4. I don't want to be here forever. Okay, so it's calc. I'm not going to do the whole thing. I'm just going to say calc r, and we say, remember, y is a changing value. So it's x for z, which then gives us z plus, because remember, 4 is not less than 1. Because remember, the base case is y less than 1, return x. So x plus calc r x3z calc r of x3z gives us z plus calc r of x2z, which gives us calc r of x2z, which gives us z plus calc r of x1z, which gives us calc r of x1z, gives us z plus calc r of x0z. So when y is less than 1, we return x. So we have x, z plus x, z plus z plus x, z plus z plus z plus x, z plus z plus z plus z plus x, which is 4z plus x, which is yx plus yz x. Okay. That's why it's important to do a trace table. A lot of you went minus y, a lot of you went plus. Okay, unless I've made a mistake, I just want to cheat quickly and double check I've made a mistake. Yeah, that's the answer. So why did I start with the 4? I started with a value where I could see the sequence. I could have started with 6, I could have started with 5. I would never recommend starting with like 2 or 3 because I won't see the full sequence. I started with a value large enough for me to see the sequence. So I looked at the base case. I looked at where the base case was going to end, and I gave myself a bit of space to see how to calculate. How did I get Z plus X? Remember, the last thing it returns is X, not Z. Look, I could have started at 6. There's no issue with if I started at 6 here, but I would have done it an extra 2 times, but I'd get the same result. With these type of questions, it's practicing. It's what it allows us to see is, do you understand that this is the base case and this is what happens when the base get happens, and this is the recursive call, and this is what's happening with the recursive call. That's what we're trying to see. Do you understand how the two combined work together? That's the point of this question. So it does take a bit of time, but a practice to get used to it, but it's testing. Do you understand what's actually happening inside the recursive function? And can you solve it based on that? Okay, how did I go from 4 to Y? The same as the previous one. I've got to get it in terms of X, Y, and Z. I'll give you another exercise now. So I remember when I started the thing, I said assume, sorry, I missed the Y. Assume Y is 4. So I started the calculation with the assumption that Y is 4. So if I put a value of, say I did this, 20. Answer would then be 20 Z plus X. That's the point of it. The Y is a representation of how many times it's going to repeat. So keep that in mind when you're doing. The point of me substituting back is to show how it would work on generic, how to get a generic solution to any given value, depending on what Y is. Okay. Let's see what this one is. Oh, damn, that's just evil. Let's go with this one. There's another one. Try that one. Trying to think. I think I made this one. It's an evil one. I'll give you that. We should have enough time, Omar. I'll get to that as well. Okay. I'll give you guys 5 minutes for this one as well. It's actually not as hard as you think. Okay, they'll give you a hint. This is your base case. This is your recursive call. So this line is your recursive call. This line is your base case. The assumption's up to you. You must just remember, recursive starts with y must always start with the value of y greater than or equal to 3, else it won't work. That's a very important point. Okay, ladies and gentlemen, I was actually just chatting to Mr. Van der Vestes on the side. There isn't this one. If it confused the crap out of you, it served its purpose. You can't solve it. It's not X, Y, Z. The problem with this one is every time you loop through, this value changes. I realized a second after I put it up, the problem is we wanted to see how long it would take you guys to realize it can't be solved. With what we've taught you, it's. Let's see. No, no, you guys are giving me answers that are going to be messed up no matter what you do. Ladies and gentlemen, you're missing the point. What happened? Look at the section I'm highlighting right now. X minus Y. What happens to Y every single time we loop? It's always going to change. So there's no way to give me a correct answer. There's no way to give a solution for this one because y is consistently changing. You can't produce a result like this. It's almost impossible. Okay? It's not something we would give you in a test either. Because of the fact that y is also changing, it affects the calculation. So let's have a look at another paper. So let me just find that paper I have open. No, not this paper. It's structured worse than a factorial, to be honest. Uh, this one's better. This one's much better. Okay, try that one. Wait, I need one with the times in it. No. Aha, this will work. This is last year's paper. I need to show you this. This is another variation I need to show you because there's this one's solution is slightly different. It's a doable one. So try this one for a few minutes, and then I'll give you the solution. Well, I'll not give you the solution. We'll work through the solution together. Okay, so not really apologies for the previous one. That one was testing your ability to read the function and not just blindly dive in. This one will give you a solid solution that you can work through. Also, it's the 2019's paper. So try this one. This one's in terms of A, B, and C. So instead of X, Y, Z, it's A, B, C. Make your assumption on your given value. Okay, again, I'll give you guys 5 minutes. Go for it. Okay, good. I see some of you have solved it already. Let's do it together for those who are still getting there. Ladies and don't feel bad if you're taking a bit of time. This isn't thing. This will take a bit of time getting used to. It's not something that will automatically come naturally. It does take a bit of time getting used to. Mr. van der Westhuizen is actually coding out the previous one so we can see what it actually would return. So I'm going to move this off and then I'm going to do it together. So let's remember, we need to know, the first thing you always need to figure out is which one is changing. In this calculation, the value of C is changing. So we use C as our base point. So we say assume C is 4, whatever. Calc Q2 A B4. This would give us A plus B times, now this is important, times calc Q2 A B3, which would give us calc Q2 A B3, which would give us A B B times calc Q2 A B2, because every time it's going down by 1, so calc Q2 A B2 would give us A B 1, which would give us calc Q2 A B 1, which would give us A plus B plus calc Q2 A B 0, which calc Q2 of A B 0 is 1. Okay. Remember, it only stops when C is less than 1. So at 0, it's less than 1. So now we move back up the stack. So we start breaking down the stack. B plus 1. Sorry. I'm using my mistake. Times. Be careful of that. Don't make the mistake. Make sure you're doing times when need be. Okay, because remember, this is times, AB times the next one. So this is AB times 1, and anything times 1 is the same. Okay, so this is A plus B times A plus B times 1. This is A plus B times A plus B times A plus B times 1. And this is A plus B. I'm just going to make use of Excel's joyous copy and pasting functions. So we get that as the last sequence with that assumption of 4. So we have A times B times AB to the power of 4 times 1. Everyone still okay with me there? Which is then A plus B to the power of C times 1 if you want to keep the 1 there. It's not going to change anything. Okay, it's not C minus 1. Since this sequence occurs 4 times, it's to the power of 4 times 1, which is AC times A plus B to the power of C times 1. Some of you are slowly grasping it. I saw a lot of you get the right answer earlier, which is fantastic. One of you made the mistake of using Y. Remember, read your questions carefully. This question was in terms of A, B, and C. So I'm using A, B, and C here because that's what the question asked. In last year's paper, the full question was also this. So it'd say choose one of the following and show the calculation. So you could go A, B, C, give us, say it's B, and then show us how you got to B. And B is the correct answer from last year's paper, at least. Everyone okay with that? Is this slowly starting to make a bit more sense, ladies and gentlemen? Okay. Please, again, this is not this afternoon's tutorial will be about it as well. Thursday's tutorial is going to be on UML, something else. So just keep that in mind as well. What I want to show you now, Mr. van der Westhuizen did a bit of work last night, and he calculated Fibonacci out. Now, I want to just answer a few questions as well. He's not going to like what I'm doing to his code. Okay. So this is Fibonacci programmed out with the 2 different sequences, with the 2 different base cases. In your practical semester test, you don't do recursion, don't worry. Practical semester test has other problems we're going to get to later. The recursion is mainly for the theory tests. The point of this one is to show you how long it takes to actually calculate. So let's run it and see what it does. This is doing Fibonacci. Let's see what this does. Okay, so that's Fibonacci up to the 35th term. As you can see, it escalates quite far. Okay, that's Fibonacci all the way to the nth, the 35th term. And all the values leading up. Okay, I was hoping to see the underlying green here, but it's not appearing. So let's do one so I can answer the question earlier. What's wrong? Okay. Okay, I'm going to answer 2 questions. The 2 questions from earlier, the underline in green and calculating a sequence using recursion. I'm going to do an old sequence you guys are used to. Plus 31. Private function calc sequence n as integer if n equals 1, return 1 because that's the ending point, else return n plus calc sequence n minus 1. n, no, n minus 2. That would work. Still not getting that underline in green. Okay. So this is answering the question of how to calculate a sequence. This would produce the sequence for me here. For the base case. You could say 1, but it's easier just to read that it's going to return 1. How to display it? Let's just undo what I've done. I don't want to mess up with Mr. Vestazen's code too much. Button, text box. You'd say dim value as integer, value equals calc sequence 31, as that's going to be this basically the start txt display. Did I change that? Oh, change that horribly. Txt display. But text equals convert to string value. Okay, I'm gonna ignore that display. So in the button. Yeah, I'm not going to show you how you display because yeah, he's probably right. You're going to Larry Tesla the damn thing. Okay, everyone okay with this part? For the student that had the underline in green under the function, how would I get that to display? How would I get that to display? I know. Nothing to do with recursion, but it'll give me what I need to do. Okay, I'll get back to your questions now. To the student earlier, we have this underlined function in green. Okay, you can see the end function is underlined in green. This is a warning message. Okay, it just simply means that it may not return a value. Because currently with the example code I've given here, if the value is anything but 0 to 10, it will return nothing, giving us a potential null reference almost. So it's a warning. It's not going to break your code. It just might not work. But you'll notice with most of the recursive functions, it doesn't give that green because there's always a return. So just double check what's going on. It means there's a chance of it not returning a value, which could potentially mean a problem. All the green is a warning. You'll see in the other code as well, but it's potentially that something won't return. Let's get to the other questions. On line 33, why do you say -2 isn't supposed to be n plus 2? Okay, I'm working from 31 going down. If I was going the other way, then I'll be doing this. Okay. So you got to think of, yeah, I know that's probably a potential infinite loop. Preferably you want the base case to be a known value. 1 is a known value, so it's easier to work with. I'm aware, Mr. van der Westhuizen. If by any chance I do this, what's going to happen, ladies and gentlemen? Mr. van der Westhuizen's put it in chat already. Okay. If I use anything but an odd value, I'm going to get an infinite loop. It's never going to end. What I could do is less than equal to 1, and then it should stop. The reason for the infinite loop, well, remember, I'm going -2. Am I ever going to reach 1? If I go -2 and my starting point is 32, am I ever going to reach 1? I'm going to go 2, 0, and keep going. Okay, so there is the potential of skipping over 1 altogether and just keep going indefinitely, which I'll show you what happens now. It's a stack overflow. Basically, the computer ran out of memory. Okay, and I'm using a 16 gig RAM machine, so that's a lot of information just chewed up. Okay, so be very careful with that. You don't get infinite loops. Something like this is known as an infinite loop. Thank you. So just be careful. One way to avoid it would be saying less than or equal to 1. That would then stop the sequence altogether. Okay. So that would work as a deterrent away from infinite loops. For the, okay, I'll answer questions about the practical now as well. For the sequence 3, the Pernin sequence, or maybe I'm pronouncing it wrong. All we need you to do is give us the nth term. So if I say I want the 5th term, give me the 5th term, whatever the 5th term is. I don't need you to show me all the values leading up to the 5th term. I just need to know what the 5th term is. Using a text box. Okay, I'm not sure about that. Using a text box and a button question mark. Okay, someone's raised their hand. You can go and ask the question.
So, the question is mine, the button and the text box. I was asking, that given the function to display the code inside the button, I mean the code for the function, we have to do like the code for button 2. That's what I was asking for displaying.
Yeah, you need to button to call the function.
Okay, sir. Thank you, sir.
Okay, so that question is quite prevalent. remember, Legion, if we don't have this code here, we don't call the function. So we need something to trigger the functions to start to work. So we must have a button to actually trigger the functions. That's what point to the function, the button. The functions there, it works, it exists, but it's just there in terms of triggering the function to get us a result. Okay, there's 8 more minutes. Any other questions, ladies and gentlemen? If you have any questions, we can end it for today here. Excuse me. And for those who want, can join this afternoon, this evening with Mr. van der Westhuizen as well. You can talk, go. Okay, someone's raised their hand. The test data is just, actually the test data for Prac 2 would be interesting. Just say what the value of the sequence is for each one and give an example for the test data for, say, the 5th value. You can ask your question, it's fine.
So we're only supposed to do test data for sequence for the parent sequence.
So you might have answered this.
I'm getting 2 people the same one. You would do, remember, you got to test that your program's working correctly. So you would give us the value of each sequence and then the nth term, whatever you're going to use as a test term.
All right, thank you.
Okay, the other student? With the function parameters, do we need to use barref or over barval? No. Recursives are barval. Remember, bar reference is a physical copy of the data. We don't want to do that. We're specifically using bar-val here. It's definitely bar-val. Bar-ref could cause potential problems later on. I don't know. Let's try that. I've never actually tried that. Let's see what happens. Will it impact the code? Doesn't look like it. Okay, but I would definitely use a bar-val because it's just more practical for what we're doing. So is there any way, tips to make Visual Studios run faster? Your application or Visual Studios itself? Nothing really. It's going to return 1. Oh, wait, yeah, that's a good question. I think I understand your question now. If I have barref here. Let's see what happens. I think it should just still return the right value. I'm not sure. We'll find out. Yeah, it still returns the right value. Since the information has been thrown onto the stack, I don't think it's going to cause an issue with a barref, barval. I'll have to look into it. Okay, Mr. van der Westhuizen has actually done. Okay, to get your app to run faster, that's something that's discussed much later on in your career in IT. Don't worry about making apps run faster right now. Right now, just get the basics of programming. We're not going to focus on getting apps to run faster in Informatics 1. That's something that you do more in computer science. Optimization and that. Ooh, I'm seeing some trolling. Actually, Moses, in terms of ByRef with a function, it actually is useful. It does work because you can return 2 results using a ByRef. I've done it before with code. I've had to get multiple results out of, so I've used a ByRef and a return. It's kind of a messed up way, but you can do it. It's not the most appropriate way to do it, but it's okay. For those who are interested in performance, Mr. van der Westhuizen will discuss it this afternoon. He's more getting to performance than I am. I'm focused on getting you guys principles down in coding. He will do principles and techniques. Okay. But I definitely would not recommend doing ByRef and functions like I mentioned earlier. That's another story altogether. That's going into spaghetti code almost. Okay. There's 2 minutes left to the tut, ladies and gentlemen. If you want to sign off, sign off. Else, you guys can join this afternoon. Else, I'll see you tomorrow in the lecture. We'll start to finally discuss objects properly. And we will then on Thursday be discussing UML. Okay. Thursday will be part Q&A, part UML. Enjoy the rest of your day.